Sorry for the interruption of the networking. We can continue over after the lectures. Actually, can you hear me well like that? Or I can just speak normally and you can still hear me? It's okay for everyone?
Better.
Yeah? I don't hear you. Maybe you need the mic. Okay. So today we're gonna go over the top features of Zend Framework 2. It's not going to be a comparison between the frameworks, so I don't want to start a fight in between the presentation slides. So, first several words about me. Some bits, as I said. I've started programming in the early 2000s with MRC scripting. Then in 2003 I've switched to web development, and in 2006 I've switched to PHP. And so far it's one of the best choices that I've made. I've dealt with different languages, but not gonna mention that on the big user group. So I'm currently a dev lead in the MailJet team of Proxyat, Bulgaria. So that's another thing. So Zend Framework 2, it's one of the first bigger frameworks that there are in the meaning of Zend Framework. Zend Framework 2 is developed in the last several years as a upgrade of the first version, and many of the things are solved over there. So what is Zend? Zend is a framework which is quite specific, and it's not for every project that you're ever going to do. So it's not for every project, because there are different scales of the projects, and for a simple site you don't need Zend. For a simple HTML page or presentation page, you don't need Zend Framework for that. And it's one of the best features of the framework comes when the application grows and you have to maintain that application. So the other main topic of Zend is that it's not for every developer. Many of the developers are letting go of Zend because it's too different for them, too hard for them, and there are many reasons actually. And one of the reasons is that Zend Framework is not giving everything for free. It requires some learning and requires some exercises on it, so it's not automatically generating your code and you just have to type your name. It's a bit different. And different how? It's actually a library. A library, and you can use whatever you need from that library. It's not, you're not obligated to use everything or nothing like that. And every component of that library you can use at your own will. So you don't have to use any of the concrete classes that the application is providing to you all. So this is really important for the nowadays applications, I think. So not every framework is just a model view controller design pattern, and we're going to speak about that we're going to speak about the other parts of the framework, not just the MVC. So, no MVC today. There are plenty of frameworks which are covering the MVC pattern, and they are doing it great. But Zend Framework is not just that. It's giving you more. And by more, I mean it's giving you event-driven architecture. What is event? Let's start from that point. Event is a significant change in the state of a given object. If something has changed and someone else, some other class should know about this change, here comes to use the event manager. So event-driven architecture is really important for the scalability and for the maintainability of the code nowadays, in my opinion. So the other main part of the framework is that Zend is service-oriented. It has the service-oriented architecture, which is giving you loosely coupled units that can be working together and ease your day-to-day jobs or tasks. And these small services, they are self-contained. And if something is broken, you're looking into the link between the different services, not the whole package. So this is a nice feature to have for every framework. And it's not only on the framework part, it's how we build applications. So another topic that I've already mentioned is that Zend is a library, and this library is full of interfaces. And actually, you don't have to use any of the concrete implementations that Zend is providing. You can write your own implementations and just base the application on them. So we have a nice library of interfaces which are giving us a way to compose our code. So we have the practice of composition over inheritance. So the composition is containing interfaces of other classes that implement the desired functionality. And it's way better to use composition instead of using inheritance from a base class or a parent class. And that's because in PHP we are limited on that part with inheritance, as much as there are traits, of course, but still we have only one base class that we extend from. And it's a language limitation that has its pluses and minuses, of course, but it is what it is, right? So, Zend is enterprise level. It's not personal homepage level. It's not just for the small projects that we all made in between the big applications. So this is for the real applications that there are. So on the top features now, we have the configurations, we have the modules and module manager, we have the routing and how do we route the URL to a specific controller, and we have the service locator, which is providing different services that I mentioned before. And we have the events and event manager. Some topics are bigger than others, but it's going to be great if I manage to show them all now. So the configurations, we have usually, as usual actually, we have an entry script, and this entry script is doing something very important. It's changing the current directory from, for example, public index from inner directory, which is the actual part that the user executes. So we are changing that, and we are setting the parent of this directory to be the main one. So everything gets related to the root of the project, not to the public directory. So this is important in order to have a really nice and smooth configuration without dot dot slash and things like that. Well, sometimes you need it, but it's not always. So the next big part of the configurations is the application config, which is provided to the module manager. So module manager reads this config and says, okay, we have application. Is it okay? Do you see it? It's right. Yeah. So the application, when it started, the module manager received this configuration and does a loop over the defined modules. For example, here are application, third-party module, and my module. It's application specific, and it's looking for these modules in different directories, which are defined underneath over the module paths. So it's going to look for application under module directory. If not found, it's going to look for it in the vendor directory. And this is a nice feature to have in order to make your application decoupled and have a different module in a different repo, Git repo, for example. And in that way, the dependencies between the modules are getting a bit lower and fewer, and it's easier to maintain this kind of product. So the other important part is how we outload the configurations. We can define a very specific way of loading these configurations, and it's gonna the module manager is gonna follow that and merge these configurations on different levels. So here we define that the configurations should be looked into the autoload folder, and we should be looking for everything which ends at global or local.php. And then we load configurations from the environment folder for a specific environment, and we are looking for environment.php or environment.local.php. .local files usually are not committed in version control, so it's you can have them on production even without any problem, giving you only the passwords that you need. For example, the global configuration consists of the things that are never going to change on different runs of the configuration of the application. Sorry, and the database password may change, so it's not in this file. In the global files, we have things that that are environment agnostic, so it's okay for this kind of stuff to be set in those files. We have the local configs, which can be, for example, just something that we want to change dynamically in the next runs of the application, and we have the development config, which sets specific passwords or usernames that we should be using for the next calls. So what's cool about that? What's cool about these configurations? You can define the order these configurations are merged. They are recursively merged, so the order is very important. You can have configuration file per module or many per module, and each module is registering its own configurations. And the other good thing is you can have environmental configurations, and you can cache all the configurations. It's built in the autoloader and the logging system. So you can cache all that and boost performance of Zend. Many people are saying Zend is slow. Zend is slow because it's not configured properly. Usually it's like that. Our Zend is pretty fast. So the next thing is modules. I've already mentioned bits about that, and one of the big things about modules is that they work in this framework. There are some frameworks which are really complicated for the module usage, and this one is based on many projects, and it's built to be working from the first moment, and there are plenty of modules in the wild actually. So the autoloader for the modules is actually one of the things that you don't even notice. It maps your class and its namespace to a given directory, and you forget about that. It's really easy to do a new project with that, and you can of course define in the module configuration if you have different layout of the application. For example, you are trying to migrate something old to a new layout, or you want to keep the layout. Zend is giving you that with a simple configuration inside a module.php file module class. It's actually one of the base things. You can register many event listeners, so here I'll show you that later. And it's cool. And what's cool about it? As we said, you can have submodules in different repos. You can decouple your application, and there are ways to say within the code that your module depends on a different module, so the dependencies are maintained not only in Composer. You can maintain the dependencies inside the application. It's not being used that often, but still it works, and it's available. And with this layout of the configurations and modules, you can easily plug in third-party module and override the configurations of it as you need for your application. So the next topic is routing. And routing is a really nice topic to discuss maybe later, but still routing is, as defined, is the act or art of matching a request to a given controller. Many have failed on this challenge, but Zend, I think, have succeeded to do it in a really proper way. And well, in the first place, it's really heavy if you don't cache it, or if you don't do performance stuff on it. But it's too verbose. That's why it's heavy. So there are two main router types. There were plenty of way in the past. Sorry. So in the past there were different router types which are getting deprecated more and more, because these ones are really efficient and secure. So the base types are literal and segment. Literal, as the name says, is something that you match on the URL goes to somewhere in your application. It's really simple. It doesn't have any variables built inside or anything like that. So as I said, the configuration is verbose, a lot of arrays inside arrays, and yeah. The other good option is to have your own routing types. So this one is provided by Zend, but you can use whatever you want as long as it implements the routing interface. Here you can have your own class, and you can build your own router type and contribute it if it's good. So the router sends, if this matches, we go to this controller and run this action. It's really simple. So I'm not gonna take more time to explain that. Then we have the segment routing tag, which is a bit more complex. Actually, the routers and the routes itself, they can be nested one underneath the other, and you can have the main application over here, and it has child routes, and then we have the child route defined underneath. So it's more arrays, of course, but still we can have. And the good thing here is that it inherits the parent root. So we have the slash here. If there was something as word as on the previous slide, over here we had something. If this something was on this slide as well, then we're going to get it in between the dashboard and the hostname. So on this configuration we have a slash here, and we continue on with the dashboard as a word, and then we get an action as a variable. And this variable have constraints because we don't want anything to go by and to continue on in the application. So we can define them as regex, or we can define them as different type of regex with the pipes. So we can have stats, pipes, orders, in order to allow only specific keywords to be available. If the root match does not find a proper root, then we know it's 404 page, not found. And a different controller is, different event is triggered, then I will show later. So a bit more complex than the segment, but still it's quite simple to understand. And then here comes the pluses of this kind of routing. You saw we have the okay, so we have over here a name of this route, and it's called application. The next route is called dashboard. So these routes can be aliased in that way, and if you need application dashboard, you can just write the alias of that route, and the plugins that there are in the controller can give you a correct URL to that place. For example, there are several controller plugins which are params, URL, and redirect on this slide, and we can use the parameters that we define in the root and get them inside the controller. We can do a redirect directly to this specific route, and the route building, the URL building, is automatically done by the inner part of the framework of the route matching service. So that's about the controller plugins. It's not controllers, it's plugins, so it's still not MVC, I hope. So what's cool about the routings? We got the named routes, dispatching, and for dispatching and for URL building, it's actually two purposes of the same mechanism. So it provides a lot. And if something gets broken on your application, you get a nice exception saying that is not working, or you don't provide a good parameter for that rule, so you get a nice exception when something is wrong, and you notice that quickly, and you can react, of course. You got the nested child rules, which is giving you the option to have more details, and different modules can add to a specific child rule. So for example, if the one module is providing the main application, the other module is providing something behind dashboard, for example, it's really easy to maintain a thing like that. You get the constraints on the parameters on the input, which is great for most of the applications. It's the first step for SQL injections and that stuff in general. So I think that I didn't show here is that you can pass extra information inside the root, and this is being done over here in the defaults. You can define anything here. It's open format, so it's actually an array. So you get different kind of valid stuff over there, and it's going to be passed to the controller or different listeners for that specific key. So you can pass, for example, access control list permissions in that field, and there is going to be a listener, for example, which is going to follow that and restrict all the pages which are not allowed for the specific user, for example. So you can define if the user does not have access to that page, where should he go to. This is the unauthorized redirects. Well, all of these on the bottom row are implementations of our applications. They're not coming from Zend. You can define anything you want over there. It's really easy to be used. And another thing that we have done is define which of the routes can be cached and which are not. So it's saving a lot of time. Maybe the questions can be later on the slide of the. Okay, thanks. So the next topic is service locator. The service locator knows about services, of course, and in the perspective of a nice application, the service should be a black box for the ones that are using it. And this is really important to have a decoupled application. If you know that these are the methods of the service and you call it and it does its job, it's really easy to maintain a project like that. So the service is actually an instance of any object which provides some logics that you want to reuse at some point. The services are getting lazy loaded, which is great because you don't have to start all your services at once and create their instances. You can create the instance in the first moment that you need it, which is lazy loaded. Yeah. So the services are part of the application which wires the hard to do things together, and you only define what needs to be done in several rows without the hassle of checking everything if that should be done in that way or not. Actually, it does not save it, but it's helping you doing it better. So these services, they're maintained by the service locator, and they're maintained in the memory of the process. So their instance, they're shared by default, and their instance is kept and being reused, which is great. You don't have to create twice the same object and do the same stuff with it. Well, there is an option. If you need a new instance every time, there is an option to do that, of course. So the service locator is a manager which looks for specific keywords and match them to a class or instance, more or less. So there are several basis service types which are defined by the framework, or they're not defined, they're named like that. So we get the invocable services, or in other words, the invocable services are the ones that does not have any implicit dependencies in the constructor. There are factories which are a way to handle the constructor dependencies, and not only constructor actually, just dependencies. There are abstract factories which are creating an object by specific rules, and we got the shared or not shared services, which is actually the one that I mentioned earlier about having a new instance every time or reusing the instance from memory. So at last point, we had the aliases, which is doing exactly that, aliasing a service with different name. So the invocable services, as I mentioned, they have no constructor dependencies or any, they may have other dependencies, but these are not related to the service locator. For this manager, the services are created as new and the class of the object, and that's it. So if we require a service called outListener, it's going to look for a class called outListener, my module listener, outListener, and it's going to create a new instance in the most simple way of doing that. So the invocables, they're pretty easy. Then we get the factories. The factories, they are defined in almost the same way. We can define a name for it and a class that should be executed when we require this object. And that class actually is not does not inherit anything from Zend. It just implements Zend interfaces. If this class implements the factory interface, it should have a create service method which receives the service locator instance, and we can resolve different dependencies by using the service locator itself. So we can, for example, get the database adapter for whatever needs there are of this other service. And we can get the configuration. The configuration actually is a different service inside the service locator. So everything defined in the configuration can be fetched from this config service. So, for example, we have added a specific key in the configuration which contains some data, and we can pass that data to the service itself. So the dependencies are managed in one single place. Actually, you can have multiple factories for the same class, which is totally fine. But then your class is going to be with different name, for example, for every instance that you need. One example is if I want this service to connect to MySQL database and this service to connect to Postgre database, I can use the same method of creating the service but with different adapter. So it works both ways. And the other option is to define a callback which is the same as this one but in a more simple way. You can define a callback which is getting executed when somebody wants the out service in out listener in this example. So there the factors are really nice to maintain the dependencies of your code, and it's good to be used. The next topic is the abstract factories, which are doing almost the same, but with another check and another interface that we get from Zend for free. And this interface has two methods, which is can create service with name and create service with name. Well, they are quite verbose, a lot of symbols in this one. So if the name has controller inside it, we are able to manage that dependency, service within this factory. So in the first method, we are checking if this factory works for this class. If we need common controller, or well, if we need dashboard controller, it's gonna check dashboard controller. Okay, I can do a service with that because that class exists and everything's fine. And then we, in the next method, we are creating in the that instance just as invocable, but automatically. So this nice feature here, but it's not for every use case because it's doing a lot of checks in the background. So this should be the last choices of factories, in my opinion. So we got the shared, if we need a new instance or not, as I've mentioned, and we can define which of the services should be shared. Of course, we can define even Zend services over here, not only our application services. So we can manage Zend in the same way as we do with our application. Okay, so the next thing is aliases. Aliases are quite simple. We just say this class should be called with this name, and the application understands that, and you can really shorten the way you define names of classes. And of course, the other plus is saying, hey Zend, I don't want to use your authentication services, I have my own, so use that one. It's really useful, and we are not inheriting, we are just looking for instance in different place and saying this is mine, this is the one that I want to be using. Okay, so let's go about the service locator. It manages constructor injections and the way you create objects. It's really useful for refactoring. In our applications we have a common name convention. So, for example, everything which is service, we prefix it with service slash. Everything which is type of mapper, for example, database mapper or API mapper, we prefix it with the mapper prefix. And it's really easy to find which are the parts of the application that are using this specific service. So it's consistent. The service locator objects are always consistent, and they are providing you the option